In the last video, we talked all about the fetch API and how useful it is for querying APIs and getting data back. And in this video, we're going to be talking about the fairly complex topic of the event loop. So let me just write out some code to kind of demonstrate how the event loop works. Let's just say here that we have a function. We'll just call it test. Down here, we're going to run test. Inside of here, we're just going to console.log hi. Then we're going to console.log hi2. We'll just call this one hi1. And then let's do a set timeout where we're going to have a function, which is just console.log hi3. And this is going to be after 10 milliseconds. And we're going to do a final set timeout here that is after 0 milliseconds. And then lastly, a console.log of hi5. So what we're doing is here we're logging hi1, hi2, hi3, hi4, hi5, but hi3 is after a 10 millisecond delay and hi4 is after a 0 millisecond delay. So what do you expect the output of this to look like? You probably think it'll go hi1, hi2, hi4, hi5, and then finally hi3 since this one's delayed by 10 milliseconds, and all of this code will execute much faster than that. When we run this, you'll notice something slightly different. We get hi1, hi2 being printed out, but then we get hi5 being printed out, even though this has a 0 millisecond delay. Then hi4, then hi3 are being printed out. The reason for this is the event loop. Now, in order to understand the event loop inside of JavaScript, we first need to understand exactly how JavaScript is ran. And the way JavaScript is ran is actually fairly straightforward. There's something called the main thread. And the main thread is essentially where all of your JavaScript code is ran. When you run your code, for example, function test, and it goes through here, this is all running on the main thread. This is where everything important happens. But there are ways that you can run code off of the main thread. Something like a set timeout that causes you to wait for 10 milliseconds. It doesn't cause your entire program to stop for 10 milliseconds. It just says, come back and run this code later. So what it does is it creates a separate thread, essentially a separate set of JavaScript. You have your main thread, which is where your main JavaScript is running. And this set timeout has now created a separate thread. And this thread waits for 10 milliseconds and then says, okay, I need to now log out this task. And it tells the main thread to do this console.log here. So this separate thread is just waiting till it's done, and then it plugs back into the main thread of JavaScript and says, run my callback for me. Same thing down here. It says, wait 0 milliseconds, and then I'm going to plug back into the main thread and run whatever code I have. These separate threads that we create to do the waiting for us are the entire reason we can have set timeout work without actually causing our entire program to wait. Because if we did the waiting on the main thread, then everything else afterwards would also be waiting for this 10 milliseconds. So we do that waiting in a separate section of our code, a separate thread completely different from the main thread, which is where all of our main code is running. And then once we're done with our waiting, in our case, our 10 milliseconds, we plug back into that main thread. And now the main thread says, okay, I'm going to run this code. That's why, as you expect here, console.log 1, 2, and 5 all get run before this hi3 gets run, because this is waiting for 10 milliseconds before it plugs back in and gets ran. But why does hi4 run later? Like I mentioned, this is because of the event loop. So we have our main thread, and the main thread is just running over and over and over again. Essentially, it's just a cycle where it's doing things over and over and over and over and over and over and over again. And the way that this main thread works when you first load in your page is it's going to run all of the JavaScript on your page. So for example, it's going to run this code here, it's going to define this function, then it's going to run the function and run all the code inside of it. So it's just running your JavaScript like you'd normally expect. But as it's running your JavaScript, we get these things called set timeouts, which are creating new threads, as I mentioned. And those new threads just kind of get thrown off into space. And once the time expires, in our case, 10 milliseconds and 0 milliseconds, what happens is JavaScript creates a task and it says, hey, okay, you're running some code right now. In our case, we're in the middle of this test function. So I'm running code, so I can't run this other code right now because I'm in the middle of running code that I'm currently in. So instead, what JavaScript does is says, hey, I have this thing that I want you to do, so do it when you find the time to do it. So it creates a task and it queues that task up. Currently, we're running this test function. That's our current task. And it says, okay, I have a new task for you. I want you to log out hi4 because that, is a 0 millisecond delay. So immediately when we call set timeout, it says, hey, I have this thing, I want you to run it. And it plugs it into the queue and it says, hey, this is the next thing in line to do. Then after 10 milliseconds, this hi3 gets plugged into the same queue. It says, hey, I'm done waiting for my 10 milliseconds. I have some code for you to run. Here it is. And JavaScript says, okay, I'm still running this test function. I'm not quite ready yet, but when I'm ready, I'll get around to it after I finish all the other tasks in the queue. So it runs this test function for a while, goes, finally finishes all the code inside the test function. So it says, what is the next thing in line for me? Well, in our case, the next thing in line is to log out 4 because this was the first thing that got put into our queue. So it logs out high 4, then it goes around again. It says, now what is the next thing for me to do? In our case, it is to log out high 3. So that's why we get high 1, 2, and 5 being printed out, and then 4, and then 3. And the way that this event loop works with asynchronous functions like set timeout that use callbacks is interesting because when we're running our code, we essentially have our stack trace, which I've talked about a bit before. We can actually pretty easily see that stack trace if we go into our sources here. Let's just put a breakpoint here and rerun our code. And now you can see if I just pull this up a little ways. There we go. You can see our call stack, we have anonymous. This anonymous is just like our main thread. It's like our entire script.js file. That's what anonymous is here. And then we have our test function, which is what we're currently inside of. So here is our call stack. And in order to run one of these queued up tasks, because as you remember, we queued up our set timeout here, and we queued up this set timeout. In order to run one of these, we need to finish our entire call stack. So we need to finish running this test function. We need to finish running everything inside of our script.js, which is this anonymous section. And then once our entire call stack is cleared, we have the ability to add on a new task, a new thing in our queue, which in our case will be this console.log high 4, and then console.log high 3 is the next thing that's going to get run. This is the exact same way that a click event listener works. For example, if we queue up a click event listener, so we have, for example, button.add event listener on click, and we have some code inside of here. This code is going to queue up a new event. So it's going to continue to run, if it's in the middle of this test function, it's going to run all of the code inside of a test function. It's going to run everything inside of all the call stack. And then once that finishes it, it's finally going to run this code inside of this click event listener. Luckily for us, the code in JavaScript runs very quickly, so you don't notice this delay as a user because everything is so quick for you. But if you have a really slow or non-performant site, you may notice when you click on something, there's a slight delay before it happens. And that's just because sometimes you're in the middle of a really long running task. If this test function maybe took, for example, 2 seconds to run, and we clicked in the middle of that when it's only 1 second done, our click function wouldn't run until a second later when our test function finishes. It's just added to the queue of tasks that are going to be completed. In order to see this a little further, let's just come up here and put some console logs down here. We can say console.log high 6. And now if we save, get rid of this breakpoint that we set here, refresh our page, go over to the console, you can see it says high 1, 2, 5, 6, 4, 3. Again, this set timeout cannot run until our entire call stack is complete. And this console.log high 6 is inside of our script.js file, which is the bottom thing of our call stack, which means that none of this set timeout code can run while it's waiting for this high 6 to be printed. Even though we waited the full 10 milliseconds or 0 milliseconds, it just has to wait until it's the next in line in the queue, because JavaScript can only run one single task each time it goes around the event loop. You can think about the event loop as a physical loop. Imagine a car driving around a racetrack. And every single time you get around to the finish line or whatever, every single time you get all the way around one loop, you can run one task. Go all the way around the loop and you can run one more task. And you do that over and over and over again. In our case, this current task that we're on is running out this test function. And this test function takes a little bit of time to run. And then it pauses there running that. It goes all the way around the track back to the beginning again. And now it says, okay, I can run the next thing, which is my set timeout. Drive all the way around the loop back to the beginning. And now you can run this next set timeout. Now, unfortunately, JavaScript doesn't like to make things easy. So there's a separate type of asynchronous task, which in our case is promises, which we've talked about. And they actually work slightly differently than these normal async functions like set timeout and add event listener. And that's because they can run before the call stack is actually completely finished. Let's take a look at that. We can say new promise is going to be resolve and reject. All I want to do is resolve with high 7. Actually, we'll just say high promise so we can see exactly where this is. And then this is going to have a dot then, which is just going to take in the message. And it's going to console log the message, console.log message. So if we save this, you'll notice something interesting. We print high 1, 2, 5, 6, and then we're doing high promise, and then high 4 and high 3. And now if we take this set timeout up here that has a 0 millisecond delay, and we move it above, up here above our promise, you'll notice something interesting. When we save, our promise actually runs before our set timeout. And the reason for that is that this promise executes immediately when the function it is inside is complete. So instead of waiting for the entire call stack complete, all that the promise does is wait until the currently running function is complete. And since our promise immediately resolves, all it does is wait for our test function to finish running, and then it's going to run out this promise. And the only reason this high 6 is being logged out down here before our promise is just because this logging is so quick and there's not very much going on our side of our function that this promise doesn't actually have enough time to respond back to the main thread to tell it to run this console.log here. So essentially all it's saying is that this promise is slightly slower in telling the main thread what to do than just logging this out immediately. In order to clear this up a little bit, let's just get rid of this high 6. As you can see, it goes 1, 2, 5, high promise, and then we get high 4 and high 3 being printed. But the important thing to note is that this promise is actually being run before this set timeout here. And that's just because promises behave differently than normal callbacks in that they actually get queued up immediately after the current function finishes, at least when they resolve. If this promise took, 100 milliseconds to resolve, then it wouldn't occur until later because it would have to wait for the promise to resolve. But as soon as a promise resolves, in our case, it resolves instantly, then the promise is going to be run as soon as the function that you're currently inside of is finished. So it can actually insert it kind of in the middle of the call stack. It doesn't have to wait until the call stack finishes out like set timeout or add event listener need to. Now I know this is a bit of a confusing topic, but let me just kind of reiterate the exact steps everything goes through so hopefully it sinks in. The thing with JavaScript is you have a main thread, and this main thread runs all of your code essentially. And this main thread can fork off other threads that do things in the background for you. For example, waiting 10 milliseconds with a set timeout, or fetching data from an API with a fetch URL that we just talked about in the last video. That takes time and it has to wait for you to get the response back because the server is going to take maybe 100 milliseconds to give you a result back. So you have to wait in the background for that result. And then when the result is gotten back, in our case, waiting 10 milliseconds, we're waiting for the server to give us data from a fetch. Then what we can do is call back into the main thread and say, hey, I have data, run my code. And the main thread says, whoa, 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 hold on a second. I'm currently running some code. You have to wait your turn, get in line. So it gets in line. But this line is preferential in that it'll treat promises differently because promises, it wants to run quicker. And this is for promises and async await. They both work the same. So it says, hey, if you're a promise, I'll run you as soon as I finish the current function that I'm running. And the promise is like, sweet, that's awesome. I like that. But the event loop says, if you're a normal callback for set timeout or add event listener or something like that, well, you need to wait until my entire call stack is finished so I can go all the way around the loop and come back and run your code because it can't just queue it up in the middle of the current call stack like a promise can. And when you're writing JavaScript, it's not necessarily important to understand exactly how the event loop is working line by line inside of your code, but it's important to understand the general idea that you have an event loop and JavaScript can only run one thing at a time. And everything else that gets queued up while you're running something just has to wait until the next iteration of the JavaScript is complete. Luckily though, these iterations are very, very fast, especially in modern computers. So it may seem like everything is running all at the same time, but in reality, it's all running one by one based on these specific rules laid out in the event loop. And that's all there is to the event loop. And no, it may not be immediately obvious how this is all working, and that's completely okay. Maybe you want to rewatch this video to try to understand those points, but really it doesn't matter if you understand the event loop 100% perfectly. It's just a good idea to understand that it's there and in general what it does. Also, if you want to really try to dive into exactly how the event loop works, there's a video that is a JavaScript talk from a conference that I'm going to link down in the description below. It has really good visuals that explain the event loop in incredible depth, more so than you'll ever need to know in your entire JavaScript career. But if you're interested, that video will be linked down there for you to watch. Now in the next video, we're going to be talking about event delegation, which is a really important topic inside of JavaScript, so I can't wait to see you in that video.